think, should get check here. They're setting up the meeting on YouTube.
It says it's now streaming live.
Gonna refresh my page, and there it is, live. Okay, Ron, go ahead and do an intro.
Hey there, everybody. Welcome aboard. We're doing it again. It's the weekly SB, that's Santa Barbara's Astronomical Unit podcast, done live on Zoom and seen on YouTube every Monday morning at 11 o'clock. We're a little late going in, so we'll go over by a minute or two at noon. Featuring the top board club members and SBAU, I call them the Brain Trust, members and board members, and God, we miss getting together. South Coast Longtime Astronomy and Telescope Club is still very much alive, mostly because of these people we're going to meet. We're sanctioned and supported by our beautiful Santa Barbara Museum of Natural History up in Mission Canyon, where we hold our monthly meetings on the first Friday of the month, but not in the pandemic, possibly later in the year. We invite you to join SBAU.org. You want a question or a comment? We'll find out from Tom Totten here in a minute. Let me introduce the Brain Trust. Everybody ready here, ladies and gentlemen? This is Series 1, which is the year 2021, Episode 6. We got 5 of these in the can already, and now we're starting the month of April. And welcome aboard. I'm going to just say quickly that if you want to leave a comment or a question and you're watching on Zoom, you can do it in the chat box down below. Tom Totten will introduce you to here in a minute, and he'll tell us more about it. But right now, on my screen, President Jerry Wilson. Good morning, sir. How you doing? All right. Outreach Coordinator ChuckMcP, are you on board?
You're muted, Chuck.
Good morning, yes.
Chuck, those short naps are great, aren't they? At your age. And the distinguished webmaster and technician himself, Tom Totten, who's now in control, and I can't see any pictures because of my problems I'm having here. But
Tom Whittemore is here too.
Oh, is Tom Whittemore? There he is.
Morning.
Our Captain Sourdough, the bread baker. My God, it's. Let me ask you this, Tom, real quick. Tom Whittemore, are you missing your science instruction there at Westmont College, or you just loving retirement?
Yeah, I missed the contact, the activities. Sure. Yeah.
Are you going back after the pandemic's over?
I doubt it. I think I'm sort of retired, so. Yeah.
Well, your house smells nothing like but incredibly fresh baked bread. I got it.
I
just finished your loaf, so I'm going to be ready for another one before long. Welcome aboard, Tom. We may be joined by one of our distinguished members who happens to be president of the Santa Barbara Theater Organ Society, Bruce Murdoch. Is he on screen yet?
No, he's not here yet.
Well, I thought before we start on the talking points, we might kick this thing around about tomorrow night's double whammy. We have our telescope meeting, right? Our online telescope workshop, followed by a tour of Mount Wilson virtually. Is that possible? Is that true? Anybody want to talk about that?
Yeah, Mount Wilson is hosting a star party looking through their 60-inch telescope with they identified the camera, but I forget what it is. And they will take questions and do a lecture while they show different objects. So that starts at 8 o'clock. And we're going to try, and I believe that our plan right now is to have our meeting from 7:30 to 8, have a quick telescope workshop meeting. So our members can join the Mount Wilson star party.
You know what? I happen to write down that camera. Doesn't mean anything to me. I wouldn't know, but it's an ATIK, ATIK Horizon 2 CMOS full color camera.
Okay.
And they're going to watch planetary nebulas, galaxies, double stars, maybe a planet or two. And anybody that wants can go online, or do we have to make reservations?
It's on YouTube.
Yeah.
It does. Oh, it's on YouTube. So we watch it on YouTube. Okay.
That's the
well,
same camera that Bob Richard uses, that camera. It's maybe an updated version of that.
Well, I assume, are we going to adapt our telescope workshop online? Maybe close it a little early?
Yeah, exactly. Yes.
Okay. So the guys that go on, how many are usually on that? I have yet to join that meeting because I wouldn't be able to contribute much. I'd love to watch it, but it's every Tuesday, what, 7:30 to 9, right?
Yeah, it is.
Mhm.
And we've been running between 6 and 12 people, I think, if memory serves me right. Is that right, Tom?
Sounds about right. Yes.
Okay, Tim Crawford, he's a big part of that.
Yeah.
Whittemore, you're big on the telescope. You started the one at the museum, I guess, years ago, didn't
Right.
you?
Yeah, I started that. So
Yeah, that's
So-
what this is
So-
continuation of this.
So Tom Totten, what do you think will happen? You'll just do a short version and everybody jumps off and onto YouTube?
Yeah, I think that's probably the best way to go for tomorrow night. Because if people go directly to YouTube on their own computers, instead of coming through our Zoom meeting window, they'll get the best clarity of whatever Mount Wilson guys are showing. So it should be good.
Okay. Lady's name is Jenny Cresto, Glendale Community College, along with her husband, Dr. Chris Burns, pardon me, of Carnegie Observatories. Let me get this PSA out real quick, and then we'll jump into today's topics this week. Science and Engineering Council of Santa Barbara is going to present Dr. Andy Howell on Wednesday, April 14th. Got a couple of weeks on that, or maybe next week, I guess. Noon to 1:30 p.m. on Zoom. It's free. He's going to speak on LIGO detection systems, reporting some gravitational waves. His talk is called New Insights into Exotic Explosions from LCU. They're our good friends. Just in case.
LCU,
LCO.
LCU. Try to get those guys in as maybe one of our first speakers. But if we ever do get the word to open up, and let's say late summer or the fall, it'll probably be Jerry Wilson talking, and maybe you can say a few words, Whittemore, and of course Chuck, the outreach guy.
Yeah, I'd
Speaking
be
of that,
happy.
outreach, what's the status of outreach, Chuck? Before we start our topics.
Pretty zilch. I mean, other than these video things, there's not much going on.
Well, you did one online, and how in the world did that follow to get place? How did that happen?
We did two. We did one for Ventura Charter School, and we did one for Santa Barbara Junior High School. And those are teachers that every year would contact for an in-person outreach. But since we couldn't do it this year, they asked if we could do it, virtually. And so we did. We just Javier would set up a scope, and he had a camera, and I set up a scope with a camera, and we did it over Zoom.
Okay. Well, maybe a lot of other schools and institutions that have used this over the years to actually come and literally set up our telescopes aren't even aware of this. Maybe they should be allowed to know that you'd be happy to go online. You just don't go outside anymore. That's the problem, isn't it?
Yeah.
Well, yeah, we just don't go outside with groups of people. But I think they're having enough problems just setting up to teach safely without worrying about trying to do something at night. That's usually a big hassle for them. These were schools that had already had protocols in place for doing Zoom with their.
Did we lose you?
Chuck got muted again somehow.
You're muted, Chuck.
Well, yeah, I'm trying to hold down the space bar. Maybe I should just permanently unmute myself. But yeah, most schools are just right now too busy worrying about how to meet safe to try to do extra things at night.
Two of our members, are the beloved astronomy teachers up at City College, Sean Kelly, and is that his name?
Yeah.
Yeah, Sean. Mm-hmm.
Okay, and Aaron O'Connor. Has anybody talked to them about how classes are going online?
I talked to Sean the other day because there's 100% asteroid occultation coming up at the end of April, and he was interested in doing things like that with his students. He says he's just too busy teaching, trying to handle the teaching load right now with the safety protocols, but he's hoping he can escape that evening and try to look at that occultation.
But the reason we cannot hold our Saturday star parties on the second Saturday of the month, since the museum, is open, but for reservations, by reservation, and they got the dinosaurs back along the creek there. Just too close together, people getting in close and looking in the lens, that's not acceptable even at nighttime, is it?
That plus we have to talk to the people, and talking tends to project the virus. And we'd be doing it on video cameras if we did it, which they could just get online. And another problem is, I think you're
Right.
limited to gatherings of unrelated people. There's a limit on the number of people of something like 25 or 50. I think it's 25. So we would have to take reservations. We would have to limit the number of people that showed up. I think it's just too much of a mess.
Mr. President, Jerry Wilson, has there been a thought kicked around about maybe a virtual online business meeting, assuming anything comes up we could talk about on a second Saturday?
Yeah, we had taken a step toward having one the last Saturday, but I had a conflict, and so we decided to find a new date and time for it. So, but we would meet once a month, and we just have a brief meeting of what we hope to do and when we hope to do it. So the meetings always preceded the monthly star party out back at the museum.
Right.
Those will not occur this time, in-person star parties, as Chuck just went over. So we don't have a lot to talk about, but we will keep in touch with each other. I miss the meetings. I miss all the people.
And the pizza.
And
Go
the
ahead.
pizza. And obviously, we're not going to have a big field trip on bus to anywhere this year, are we?
No.
Well, it's the obvious talk of everybody, including network news. It's Perseverance on Mars. You want to head into the main topics of the day, the big helicopter flight on Sunday coming up? What's the word about the pictures you've been sending us, Jerry? Those are awesome. Clouds in the sky over Mars, a rainbow.
Oh, yeah, I just call that eye candy. The rover Curiosity took through its navigation camera, NASA released a photograph of cirrus-type clouds in the atmosphere of Mars. Can you show that, Tom?
Yeah.
While we're talking,
Yeah.
Curiosity's still sending us stuff, even though Perseverance is doing very well. Percy and Ingenuity, and we're getting, forgive us for this. Well, there was a lot of stuff sent by our president to all of us. And look at those clouds. That's crazy. Is that water vapor?
I believe so.
Yeah, there's a cirrus.
Yeah.
Really?
Mhm.
Well, it certainly doesn't rain. That dust never falls to the
No,
earth.
but there's another picture that confounds with rain too. The Percy has taken a picture when it dropped down the Ingenuity helicopter and then it drove away from it. It captured part of the sky and there's a rainbow in the sky.
You're kidding.
It's the most recent picture I sent you late last night.
I saw
Hold
that,
on.
but I didn't get the background of it. How in the world does that happen on a
Same way it happens
Planet-
on Earth. There's an optically transparent medium that lets the light in, and it has the droplet or whatever it is has chromatic aberration and it splits the light into colors, and you can see the colors on the.
Mhm.
Now, whether it's produced in the lens of the camera or in the atmosphere, I believe it's the consensus is that it's in the atmosphere. But it probably isn't water vapor. Well, it could be. You've got clouds. So, but basically, I don't know. Those two, this one and the previous one, for me at this point, fall into the pretty picture category.
Huh.
So,
Well, does science know how rainbows are made? Aren't they just water
absolutely,
drops?
it's very simple. Yes. There's a
Okay.
lot of diagrams you can find in textbooks and online that shows a ray of light entering a spherical water droplet and
Right.
hitting the back. And then as soon as it enters the water droplet, it starts splitting into colors, and then they bounce off the back of the water droplet and they come out the front, continuing to spread into a rainbow. And then they come out the front, and that rainbow is what you see from the ground.
There's a
Right. No,
great-
Isaac Newton, who first described the physics of it.
Yes.
There's a great webpage called Atmospheric Optics that's run by a fellow in the United Kingdom. So it's something like atoptics.uk.co, but you can Google it, and he will explain what's going on with all kinds of halos and glories and rainbows and double rainbows and any kind of atmospheric effect like this.
Now, going back to, for a real brief, Tom Whittemore mentioned Isaac Newton, who was a true genius. But he getting to Mars, navigating to Mars, hitting Mars, and landing that's all done with Newton's mechanics, Newton's mathematics from the 1660s. So there's nothing else. There's no general relativity corrections to that. His mechanics is accurate enough for us to do interplanetary space travel.
Well, what was it that Einstein did that overturned Newton? What was wrong with Newton?
See, the perception is, I mean, in science, Newton's laws of mechanics applied in a certain range of sizes and masses, and like on the laboratory scale, or the distance between an apple tree and the ground, or the moon, things like that. So that's still very, very accurate. You probably aren't going to notice anything that's insufficient in that or needs correction. But there's a few things around the edges that they were not capable of looking at so well at that time. And that is, for example, the orbit of Mercury. It didn't exactly repeat itself. It precessed. And Newton's mechanics could not account for that. So under very high gravitation, that's when general relativity did that final correction. It doesn't overturn the previous stuff. It just adds the next term in the power series of truth, you might say. So Newton's stuff is accurate in the range which he was describing, but now we can see beyond that range, and another law is needed to make the corrections that make that work. And it looks like there may be something beyond Einstein's gravitational theory that we may need to do, because as I'm sure everybody knows, the two great theories of our time, quantum mechanics and gravitation, are not really described by one theory, yet we're in one universe. So somehow those have to be brought together. And so that's a missing extension of those theories. We know it has to be there, but so far haven't figured out how to write it.
Something interesting that's going on now with the Gaia spacecraft doing very accurate measurements of positions of asteroids and stars. When they're doing these asteroid occultation predictions, especially for trans-Neptunian objects, stuff that's far away, they're actually having to add in relativistic corrections to get the best prediction for where the shadow is going to appear and when on the surface of the Earth, even taking into account the sun distorting space-time. So it's really getting accurate these days.
You say shadow on the Earth. Are you talking about the occultation? Is that the same thing as casting a shadow? Is that what you're calling it?
Shadow, you mean shadow on the Earth?
Well, that's what he said, shadow on the Earth.
Okay, yeah.
Like
those. You said of.
Okay, have you been occulting lately, Chuck?
This morning at about 1 a.m. with the wind practically blowing my telescope over.
Really? Did you spot it? You spotted it, you zero in on the star, and then at the right time, they tell you, you verify it blinks out.
Right, or somewhere near that time, depending on the accuracy. Yeah, it looked like it was a positive. There's a lot of noise because the telescope and the sky was shaking around so much that the stars look like dandelion puffs in the video. and so there's a lot of scintillation noise and stuff. So I have to still take out a better analysis. But I did a quickie this morning, and it looks like it's a positive.
Okay. Oh, good.
Well, later in the hour, we're going to bring up the variable star of the month, R. Leonis.
Okay, so then another picture down there of Mars, it shows Ingenuity tight up underneath the Perseverance rover. It hasn't been set down on the surface yet.
That's not animation this time. I've seen it many times, but an animation looks almost as like real.
Right, but this is a still picture.
And they did set it down.
That one?
What, Chuck?
Yeah.
They did set it down. There's a picture with it sitting on the surface.
Yeah, the next one out after that. Yeah.
You know what's going to be on sale within a year? Everybody's drone is going to look like that. They're going to have the little 4 legs sticking down at an angle.
Yeah.
But they're taking.
Already do. And then there's a projected flight path. The next one after Perseverance is still holding on to Ingenuity. It shows the concept of the flight path, no specific ideas. I don't know if the landscape they're representing is real or not, but this is what they're thinking of for, I think, a 30-second flight.
Okay. and it's got the battery, not very heavy. It's only 4 pounds under those
4
two.
pounds, yeah.
And Sunday the 11th, this weekend, they plan that first 30 seconds. Are the cameras going to be on, you think?
Oh, yes.
Really?
Yeah.
And so that they'll have many flights. What if it doesn't work? What? They just
Well,
let
then
it.
they have learned something.
Very expensive. How many millions did it? Of course, a lot of it was free, testing and all. But
Yeah.
maybe it'll work if we can have clouds and rainbows in the Martian thin atmosphere. Maybe we can support a little helicopter. Why not? Ingenuity.
Someday we'll see two people sit on a bench watching the sunset set on Mars, having some wine. So Tom, if you go to the other picture, it was, I think, a separate email that shows Perseverance or Ingenuity sitting on the surface just after Mars or Perseverance let it go.
Yeah.
But it's not in the first email.
Wow.
That was the email before that.
Oh, I thought I had it here. Hold on.
Yeah.
Let's see.
Okay. If you can't find it, it's not that important.
Should be
Well, now,
here.
Mars's sky is not ever blue, is it? It's totally reddish or yellowish.
Ironically, it's reddish. I mean, it's blue at sunset. Like the Earth's sky turns red at sunset, the Mars sky turns blue at sunset.
It does.
Jerry,
Okay.
is that the picture you're talking about?
Yes, that's the one. Thank you.
Yeah.
So you can see the wheel marks of Perseverance as it drove off. And so this is what's there now, although Perseverance is farther away from it. This is the Ingenuity sitting now on the Mars surface, ready for takeoff. It's got to wait for its air traffic control clearance for the traffic up there.
So science considers Mars has weather, doesn't it, with its dinky little thin atmosphere?
It does. It has weather. It has winters, spring, summer. It also has dust storms and ferocious winds. I believe that's the one that has winds up to what, 300 miles an hour or something, or is that, I'm thinking of another.
Two or 300, yeah.
2 or 300. But the density of Mars' atmosphere is only 1% of the Earth. So that would be like it would feel to us like a 3 or 4 mile an hour wind here on Earth.
Oh,
The pressure it produces.
Hmm.
So
Well,
if you saw the movie with, who's that guy that?
Matt Damon.
Matt Damon, yes.
oh.
Where he got blown around on Mars, that was bogus science. That's not right. That wouldn't have happened.
Tom Whittemore, you've been seeing these pictures. Any comments from you?
No, I'm just enjoying, Jerry keeping, track of all this stuff.
Well, the part that's surprising me is the water vapor part. I'm wondering, does that evaporate out from under the Martian surface? Does it? I mean, it doesn't come back as rain, as far as I know, but where does it come from, or does it just stay in the air, the water vapor, H2O?
Last month, we spoke about the water on Mars. Apparently, there's a tremendous amount of water on Mars still, enough if it were on the surface to produce, say, 100-meter deep ocean over the whole surface. But it has sequestered inside Mars by being soaked into minerals, hydrated minerals, and it's all held inside the planet. Now on Earth, that happens too. Water gets sequestered in the minerals and it gets subducted. But on Earth, we have active geology and volcanoes that blow it back out into the atmosphere as water. And a lot of the explosions you see on, for example, Mount St. Helens, that was a steam explosion where a lot of water got heated by the magma and it blew the side of the mountain off. So on Mars, there's no tectonic activity like that. There are earthquakes, but not really anything dramatic like Earth. So that water never got blown back out into the atmosphere. It's sequestered into the planet and it stayed there. But it's there, so we can mine it. We can break down the rock and smelt it, you might say. I don't know what the right phrase for getting water out of the rock is. Dehydrate it. So everything we need is on Mars. It's just not in a pick it up and use it form. We have to process it.
Just got a text from Tim Crawford. I guess he's not using the chat feature here, but he was asking if the idea is to colonize Mars, how do you sustain a breathable atmosphere? And really, you're going to have to, at least at first, use domes or buildings or go down into these lava tubes, and seal them up and have a pressurized environment where you keep it.
Yeah, if we crack all the oxygen that we can get a hold of, we can sustain a breathable atmosphere for a while. It doesn't have it does get blown off into space by the solar wind, by the proton bombardment. The biggest problem, though, on Mars is not, in my view, is not getting water or oxygen. It's being safe from the solar radiation. And like Chuck said, you have to be down in some kind of lava tube or have 3 or 4 feet, maybe a meter or 2 of soil above your head in order to be safe from the radiation. So that's the big problem, because Mars does not have a magnetic field to speak of to protect it from the solar wind like we do. And especially it doesn't have an ozone layer to protect people on the surface from the ultraviolet that is so necessary for life on Earth. But those are problems that can be solved. All the resources are there.
What is the highest temperature it ever gets to? Does it ever break freezing here?
Oh yeah, on Mars, it gets up to around 70 degrees Fahrenheit on an isolated basis in the middle of summer.
You're kidding.
Something. But,
70? That's what we're going to have today here in Santa Barbara.
Yeah, something like that. It gets in that range, as I recall reading. Maybe there's new information that's more accurate than that, but...
that's what I've heard too.
Yeah, okay.
Well, then some of that underterranean water that's buried on Mars could be in liquid form, you think?
Oh yeah, it could be.
Really?
There's controversy about whether it is during hot spells, it comes out of the sides of cliffs and it runs down in rivulets down the side and leaves dark stains. It could be water, highly salted water, or it could be just dust that runs down. Both sides have evidence to support their view, but I guess you just have to be there to see.
What's that a picture of? My small version doesn't.
This is a proposed way to shield Mars, to keep an atmosphere, shield it from the proton bombardment from the sun. So you put a device at the Lagrange point 1 there, and you generate an intense magnetic field and you shield Mars.
So yeah, there'll be a big nuclear reactor there or some way of generating current that creates a magnetic field. It's going to be a hell of a magnetic field. Anyway.
It'd have to be an awfully big device at the Lagrange point.
Not so much, I don't think.
Really?
Just powerful.
Yeah. I've read of that concept. I haven't seen the details of it.
I'll be darned. Interesting. Okay, so between Perseverance and what's the only other Curiosity's the other rover that's still working? Any of the others? We got about a half dozen up there, don't we?
Sure. Is Curiosity still working?
Yeah.
Yeah, okay.
Well, which sent us the clouds pictures? That was
Curiosity.
Oh, okay.
The caption under I think I've included a caption under the picture.
Yeah, I thought it was
Curiosity.
Yeah.
Oh, it is Curiosity. Okay, and then there's what are the other names? Opportunity? That's Spirit, not the name of it.
There was Spirit and Opportunity, and then the little rover that was a Pathfinder rover, just a little shoebox size one. But those are all broke.
It was Sojourner.
Sojourner, that's it.
Sojourner. And China is orbiting Mars with their lander, and it hasn't landed yet, right? Still?
Oh, right.
No.
We don't know when that's going to happen. Gentlemen, let me do a real quick reminder that SBAU video audio podcasts are done every Monday morning at 11 a.m. right here. Can be seen at our SB Astronomical Unit YouTube channel. Link is on our webpage, sbau.org. Tell your stargazing friends and join us. We're going to be a force to be reckoned with when we come back. Can we do the nightly sky, gentlemen, based on what was texted to us, sent by Mr. President Jerry Wilson?
Yes.
Day at a time. Here's what I have written down, just the opening statements for Monday, and that would be Saturn's large bright moon Titan.
Yeah.
Passing south of the ringed planet, daytime here in the north. And you can see that that moon on in your telescopes.
Yeah.
It's Titan is visible even in a small scope, but you have to have it's early morning for us right now, and you'd have to have pretty good atmospheric conditions, although Saturn's getting higher.
And I guess Galileo saw it was one of the 4 little dots.
No, that's
No,
Jupiter. You're thinking
Jupiter.
of.
Oh, it's Jupiter. You're right. Well, he did see something around Saturn. He saw that the ears turned out to be the rings, but did he see any of the moons
No.
of Jupiter?
No.
He didn't.
No, he couldn't look
Saturn.
at detail.
Okay, I got corrected on that, gentlemen. Shall we go any more on that?
So the sky picture that's shown there is the morning sky. It says April 6th, 1 hour before sunrise, looking southeast. And this is a preview of the summer constellations with all the myriad of it's a target-rich sky for nebula and star clusters. You can see Sagittarius and Capricornus, and of course off to the right is Scorpius. And those are the summer constellations, but right now we're in springtime, so these are morning constellations. They'll be more easy to see for outreach and stuff if we get to that by July and August of this year. So you won't have to get up so early to see all this stuff. It'll be there in the evening sky in about 4 or 6 months.
Well,
Okay.
I actually saw the moon this morning at about 4 something, and it was above and to the right of Saturn. Saturn and Jupiter are very easy to see in the morning sky before the sun comes up.
And in the evening sky tonight, we'll have a pretty nice ISS pass, starting at 9:07 in the west-northwest, ending at 9:10, so about 3 minutes total. It'll get to magnitude -2.1.
Wow.
It's going to rise below Perseus, go through Taurus, and then go through Orion. It's going to go very close to the Great Nebula in Orion, very close to M42. Right. And then it's going to go by Sirius, and when it gets near Sirius, it's going to go into the Earth's shadow and disappear.
Okay.
Is that something that we can only see? Is it impossible to take pictures of that little dot?
No, it's easy.
There was a really nice video on Facebook yesterday or the day before where a guy with a telescope had actually rigged it so it would track the space station as it went over. And you can see details on it from Earth. You can see the solar panels and the different components. And first it's quite small, and then it grows and gets real big. It's an absolutely excellent job of imaging and tracking. I've never seen that before.
And on spaceweather.com in the last couple of days, there was a great image where somebody captured the ISS transiting the moon.
Oh, yeah, I've seen that.
Yep. Oh, going across the moon. One
last comment about this picture with the moon joins Jupiter and Saturn. You see there's a bar on the right side of the picture that shows 10 degrees.
Mm-hmm.
And of course, the moon, it's not claiming that the moon is to scale, because the moon is really half a degree apart across, and it looks like it would be about 5 degrees across. But the 10 degree apart legend down there, if you hold your fist out for the average person at arm's length and project it against the sky, depending on the size of your hand, that's about 8 to 10 degrees.
Right. So I was just going to mention that about a month ago, when the moon was roughly in this phase, Mercury joined Saturn and Jupiter and the moon. It was kind of neat, but it was fairly brief. It only happened in a morning or two, and then Mercury descended. It went away.
Okay, good.
Yeah.
Thank you. Tuesday.
I get up early.
But a full moon fills what, half a degree?
Yeah.
Yes, half a degree, just like the sun.
Okay. So you just take the number 360 and double it, and if you fill the sky with moons, that's how many you'd have, right? 700 something.
A belt of moons around the Earth, yeah.
Yeah.
Wow. Can we go on and do Tuesday? This is according to Sky and Telescope magazine.
No, this is I clipped these out of Astronomy magazine.
Oh, Astronomy.
That's the one I have a subscription to.
Okay, maybe
Telescope is great too.
Okay. It says maybe you've been talking about this already. I'm not sure. The waning crescent moon joins Jupiter and Saturn. That's what we've been talking about, right? That's tomorrow.
Yes. Yeah.
Capricornus. So let's go on to Wednesday. Something about a dwarf.
I got one more thing for Tuesday.
Uh-oh.
Tuesday, there's a really bright ISS pass from 8:19 to 8:25, rising in the west-northwest in Andromeda, setting in the south-southeast, sort of by Canis Major. So it's going to go all the way across the sky and be fairly bright. So that's another thing to look for. That's just naked eye.
Let's see now. Hour and a half it takes. We go around the Earth in about an hour and a half, right? 90 minutes, give or take.
ISS, yeah, 92 minutes.
Okay, well, that's about the time it's always been, whether it's Mercury or Apollo or Gemini. They all took an hour
low
and a
Earth
half.
orbit.
Yeah.
Just gonna mention, Chuck sometimes posts these things on EdHat. It's really nice.
Yeah, it's up on EdHat.
Okay.
Oh, you got it there? Well, my question was going to be how many times a day would bring that sucker back across? So again, the same one, right? ISS twice a day apart?
Go around once.
Yeah.
But it doesn't come back to the same place.
Same spot. Yeah.
Is it
the
a
Earth
different?
is rotated under it.
Yeah.
Are they different angles? It comes northwest to southeast, and then it goes southwest to northeast.
Yeah. Usually there's a transition, and usually there's a sequence of about a week, at least at this time of year, where you see evening passes and you see them transition from that more southerly trajectory to a more northerly or the other way around.
Okay. Why is the Chinese space station empty? You've never told me that, I don't think.
They haven't sent a mission up to it lately.
How long has it been up there?
It's in a pretty high orbit, so it's several years.
Oh, it's higher than ours. And
it's
they
comparable
sent it up
to the ISS.
So someday they're going to send astronauts up to their empty space.
I think that mission is over. They're building a larger ISS-like, but not that big, but they're building a larger module space station for themselves. By
Similar
the way,
to Mir.
see it, Baron, but Bruce joined us.
Oh, Mr.
It's taken me
yes,
taken me over a half an hour to get logged onto this Zoom thing.
Well, welcome to the club.
Okay.
All I'm seeing is you right now. I'm superimposed over my inbox, but that's all right. They tell me I don't get to see my ugly picture. Thank God, but it's still going out.
Okay.
On the bottom of my Zoom screen, I've got a bunch of little dots, and depending which one I hit, I can see all the participants. I can see right now, I see Jerry with me in the little corner. So I have a lot of choice of what I get to look at.
Yeah.
Well, maybe I won't have to blame my laptop. I don't have those little dots. I was looking for them earlier.
Somehow you've hidden them, but we'll find them for you later.
Well, my my tablet computer is a touch screen. So little dots, I can touch them and select various views.
Yeah.
Oh,
if your laptop isn't a touch screen, then you're going to have some other way of doing it.
Yeah, the mouse will move over it. So.
And in my case, I got a pad. I got to use my finger on a pad, and maybe it's gotten oil or something. That was my problem with touch screens years ago. The screen gets oily, and it doesn't work after a while.
Well, I use this little tool, which has got a rubber tip on it.
Oh, that works.
I bought 15 of them for, I don't know, $5, something like that, on the internet.
As president of the Santa Barbara Theater Organ Society, anything going on during the pandemic for you guys?
No, well, yeah, we had a group came in and photographed the organ, did a video on it.
Oh.
And it's going to be hopefully up on KUIT. I don't know what it's going to be called, but in terms of the theater's closed. It's been closed, I don't know, since January or earlier. And so we've done a lot of work on the organ, but we haven't had any public outreaches. We don't do our monthly open console.
Yeah,
kind of dead.
Sounds pretty much like an astronomy club I know about too. They're not doing any
for the same reasons.
Yeah, but you'd think some of those big pipes would need to be tested at least, or do they grow out of tune, over time?
No, the tuning of the organ, we tune before every concert and every presentation that we're going to use. And the flue pipes, the ones that are whistles, they all go up and down together because their pitch is related to the length of the pipe and the velocity of sound. And the velocity of sound is a function of temperature, pressure, humidity, principally temperature. So as the temperature goes up and down in the theater, that they go up and down. The other ones, the reeds, which are called flues. I'm sorry, they're called reeds. Anyway, they do whatever they want.
Oh.
And so we have to touch them. We go through a tuning, and then just before a presentation, we'll go in and touch up some of the small little buzzy reeds that have a tendency to drift.
You know, I was thinking we were trying to come up with a theme. You might, when we do open again, get a guy to do the Jupiter segment of Volsa's The Planets.
Oh, yeah.
That's public domain. We could play that if Tom knew how to call it up and use it in the background. I think it was used on the Huntley-Brinkley report once, something like that years ago. I could be wrong. Yeah. Gentlemen, well, shall we go to the next day?
Wednesday?
Well, yeah, Ceres is a dwarf planet. So I had written down the largest asteroid. Does that make it not an asteroid, but it's in the belt, right?
No.
It's both.
All right. And we visited Ceres. It's what, about 300 miles across?
600.
Yeah.
The Dawn spacecraft, trying to remember that one. How long ago was that? This is Wednesday at the 7th.
5 years ago.
Okay, midnight. Did we land on Ceres?
No.
No, we just orbited it. But you notice on the picture with this, it's a cutaway view of Ceres, and it shows the composition on the inside as measured by, because as the spacecraft goes by, you can feel the gravitational field, and you can back out what the inside structure has to be on it. And this asteroid, even though it's the largest one, it was never it was never molten. So it
never differentiated.
Say what?
Never differentiated.
Right, it never differentiated. It never formed a super dense core. So this one has got, and in the caption at the bottom of it, I'll read it to you so you don't have to see it. Because I know words distract from the picture. From the surface, there's a thick outer crust composed of mixture of ice, salts, and hydrated minerals, and an intermediate layer, that's the second brighter green layer in there, containing some salt-rich liquid or brine, and at the center is the mantle. There's no core, which is dominated by hydrated rocks. And that's what happens when you have an undifferentiated surface or structure. And you can see that bright spot in a crater. I forget the name of that. It's got 2 O's, I think, in it.
Akator.
Oh, yes, thank you. And you can see that white spot way far away, even though you can't resolve it. It's a very, very bright spot. But it's brine that's come out to the surface and deposited salts on the surface and makes that real bright spot. Another one, the second largest asteroid, Vesta, that one has as a small body, even though it's smaller than Ceres, it is differentiated. It did at one time, the planet or the dwarf planet was molten, and it formed a roughly iron-rich core. So its internal structure is very different than Ceres. And this shows that the asteroids represent very wide range of compositions and histories of how they formed. And some of them are considered to be big fluffies. That is, they are just piles of gravel.
If you were to superimpose that over the USA, would it cover what, Texas?
About
Alaska?
600 miles, it'd cover 2/3 of California.
Oh, what would we weigh? What percentage of my weight if I were standing on Ceres? Did they know?
Oh yeah, you figured out easily, but I don't recall.
Well, by the way, Callisto has the same sort of structure as Ceres. It's undifferentiated.
Huh.
Yeah.
So there are 2 different dwarf planets. One of them was molten but smaller than Ceres. That's interesting.
Yeah, that's Vesta, the second biggest one.
it's a potential dwarf planet. They haven't classed it that way yet.
But it's in the asteroid belt.
Yes.
So it is in the asteroid belt. Ceres is a dwarf planet because it's round. Vesta's not round-ish.
Is that the one on the left in the picture?
Let me see.
Yes, the walnut.
Yeah, and these are the.
It looks more like a baked potato, Chuck.
But it does have an iron core.
And how in the world did it get enough pressure to get molten back in the early?
That mass scrunched itself together. How it got molten and escaped being spherical, I have no answer for.
Well, it's really been battered. It has a huge crater in one hemisphere, so it was larger at one time. So this may be partially just the core.
Yeah, good point.
It also has a snowman there you can see on the northern, if you take up as north, the northern hemisphere, you can see a snowman there. Yeah.
So they think there's water in different, well, it'd be snow form, obviously.
No, I'm kidding. That's just the configuration of craters there that Tom went around.
But it looks like a snowman. I can barely
Yeah.
see it on my screen, gentlemen. How many dwarf planets are in the asteroid belt?
Only Ceres at this point.
Oh, the other is not considered a dwarf planet.
Not officially, no.
It's got to be totally globular, round, orb-like.
Yeah. Hydrostatic equilibrium.
And
I'm-
Chuck, wasn't Ceres discovered by a priest named Piazzi, like
Yes.
1800? Yeah.
1800, 1801, somewhere in there.
Yeah, right in there. Piazzi.
Well, Chuck, answer me this, Mr. Occulter. Would Ceres be occulting like crazy, just one star after another, if you planted your telescope on it
No,
any night?
space is largely empty. Well, it depends. If you had a really big telescope, you see more dimmer stars, it would occult more. But I've only seen a couple of occultations of Ceres come up in the last couple of years.
Huh. Okay. And then what's it have to do with Wednesday? We're going to get to see it, and normally we can't.
No, actually, the Wednesday article is saying it's in conjunction with the sun, so that's when you can't see it.
Oh, it does say that's at 12 midnight.
Yeah.
But that's the other side of the earth, so we wouldn't be able to see it even if we wanted to.
Well, it's on the other side of the sun.
Oh, it's the other side of the sun, but it says 12 midnight, I think, in his article here.
Yeah.
Shall we go to Thursday? We got about 15 minutes. Before sunup, we're back to Atlas, the comet C-2020, discovered last year.
Yeah.
Amid the angled plane of the Milky Way and Aquila. Closest approach to Earth will be the 23rd of this month. Jerry?
Yeah. And you see that this is going through a very rich part of the Milky Way, up in Hercules, where you have M13, the star cluster, and the Ophiuchus, the 13th sign of the zodiac.
Oh, I love that word.
And yeah, it's a very rich, you'll be able to see this comet going past star clusters and past nebula. The circle with a cross in it is a star cluster.
A globular cluster.
Globular star cluster. A dotted circle is a nebula. So there's a lot of stuff up there to take good pictures.
Well, actually, the dotted circle is an open star cluster.
Oh, okay.
The circle with a plus inside of it is a globular cluster. And then a circle with the plus outside of it is a planetary nebula.
Okay.
So the point is, we're not going to be able to see it very well. It's lost against that panorama of the Milky Way.
No, this is like photo ops. It'll be against a rich background.
Yeah.
Oh,
So the one with the plus outside, is that like NGC 6572?
Yes, that's a planetary.
Yeah, like M27 in the upper left.
do any of you
Dumbbell, upper left.
Oh, yeah. Okay.
Okay. What is Aquila? Aquila? Is that a?
Well,
the
eagle.
is the constellation.
Oh, it's
the quill of the eagle.
Oh, the eagle. Oh, it's its constellation. All right.
Yes.
And the closest approach to Earth, that means here it says at the end 423, the 23rd of this month. Does that mean you will get better pictures in 2 weeks?
Not necessarily. Just shows the background.
What is the, how bright will this be?
Magnitude 10.
Okay. Well, we'll have to get away from the lights of Galita to see it then.
Oh, that brings up a whole other show, doesn't it? The LED lights from hell. Have they been?
By the way, the springtime version of CalStar is this week up at Lake San Antonio. You don't have to have reservations, just show up. Joe Doyle has said that he will be there Thursday, Friday, and Saturday evenings, and the weather is projected to be between acceptable and maybe not quite so acceptable.
And you're not
It's a
going.
social event.
Yeah,
And Mr. President's not going?
no.
Could be a good point to bring it up again. Science and Engineering Council, Santa Barbara, which I had not heard about. Any of us members of that? Presenting Dr. Andy Howell, Las Cumbres Observatories.
There are several members in the club.
Are there?
Yeah.
And this is the series of the network all around the world, right? Based here in Goleta?
He's with
SBAU
UCSB and he's
is
with
the Los
Los
Cumbres
Cumbres Observatory.
Yeah.
Okay.
So,
It'll be Wednesday the 14th. That's next week, noon to 1:30 on Zoom. They're going to be speaking on LIGO detector systems and gravitational waves, which would be great if Mr. Newton could awaken and we could tell him about those, what it led to. And then, of course, tomorrow night, Bruce, did you hear about the virtual tour of the Mount Wilson telescope?
It's on my calendar. I'm looking forward to it.
Okay. Do you
We've
jump
had a
on?
couple of emails back and forth that, either, because that's also the telescope workshop. And I guess the latest thing is we'll start the telescope workshop. Then at 8 o'clock, we'll segue into the Mount Wilson thing.
Okay. There's no
Is
way you
that
can
right?
integrate. You got to shut down yours and go to theirs. You can't just fade it together on the same screen, Tom Totten.
It's just that you'll get a much clearer shot if you put it on your own computer, the YouTubes, instead of going through the Zoom meeting.
But the YouTube is a one-way transmission. You get to watch, right? We don't get to talk to them.
It depends
Well,
how
they
it's set up.
should have a chat box that you could put
Okay.
comments into, I think.
Just like the thing we're doing now.
Yeah. Well, I've been told I should have my own webcast or podcast, but I told them I'm doing one. It's on Mondays, 11 a.m. Let's wrap up the week, gentlemen. Go to Friday the 9th. The moon's passing south of Neptune at 4 o'clock in the morning.
Unfortunately, at that time, Neptune hasn't risen yet. Neptune's not going to rise for our time until about 5:30. So the moon will still be close, but don't look at 4.
Yeah.
Okay. Are you saying that Telescope magazine, Astronomy magazine, got it wrong?
No.
No, they got the time right. It's just that it won't be above our horizon.
Oh, okay. Look just before sunrise in the Eastern Aquarius constellation, right? On the zodiac. All right. Nobody wants to talk about, how about the variable star of the month? Something close to Mr. Whittemore's heart. He's a Cepheid variables expert, but I'm not sure if our Leonis is one or not. It's in the constellation Leo the Lion, Eastern
No,
sky
that
after
would
sunset.
probably be a long-term variable star, probably over the course of roughly a year.
It's
Well,
Myra.
when
It's a Myra type, Tom. It's a Myra type, and the period's 312 days. So you're right.
312. Okay, it's good guess. I was going to say, the way they name variable stars, they go through the alphabet first, R, S, T, etc. And those usually are long period variables. Some of the first discovered in the constellation named. Usually.
But they're individual stars that pulsate slowly up and down.
Yes.
They're not culting each other, or what's the word for it? Binaries, or
Right. If you look at the finder chart of that, you can see Regulus way over in the far left, and very fine down there, isn't it? So you can see the other star that's referred to, and then you can see R, a faint R, just to the right of center, and there's that's the variable star. So this is your finder chart of what to look for in the sky. Now, it doesn't have all those ancient mythological figures or anything in it. This is what the sky will really look like. Yeah, Subra is the lower right star. And the green star up there with an R in it, that's the variable star that we're talking about. So this is what your finder chart will look like. And there's 1 degree marked here in a purple legend. That's about the diameter of a 25 millimeter eyepiece field of view, about a degree, that I use in my scopes to find the object. So I would put that on Subra, and then I'd go 45 degrees up for 3 fields of views to get to the star using a star hopping technique.
And don't expect the star to actually look green. That's just an indicator in the map of which one to look for.
And there's no bright arrow there either.
Yeah.
if you guys would like a little ancient history, growing up in Indianapolis when I was a kid, I had a 6-inch telescope I bought from Criterion, and I joined the AAVSO, the American Association of Variable Star Observers. And back then, you would get a chart from Cambridge, Massachusetts. that would show the location of the star of interest, and then a background field with named magnitudes of the stars in the background. And then you would have to estimate night after night after night some of these, these stars that have these long periods. So I would be out there in the ice cold in Indianapolis estimating this. So it was fun. It was fun.
How did you do on the curves?
Okay. I didn't last long because of how cold it was in Indy.
Uh-huh.
Well, if you pick up astronomy, you're going to be cold a lot.
Yeah.
Not a lot of astronomy done during the daytime, I don't think. That's the problem.
Yeah, and not long ago, Omar Blaze gave a talk that had to do with a variable star that he was not looking at because he's not really an observational astronomer, but the star was of interest to him for his research, and it just brought back memories of the AAVSO when I was a little kid for me. Okay.
Wow.
I forget the constellation. It might have been in Leo. It might have been in Gemini. I just can't remember the star that he was interested in.
Well, these variable stars, like, what does the R stand for in R Leonis? Do you know, Jerry?
That's Tom covered that by saying that they list the variable stars by alphabetical order in the constellation.
Right.
Starting with R.
The first one they find is if I believe, R. Yeah. They go S, then they go T, and then they keep going through the alphabet and doubling up on letters and things like that.
Okay. Sounds.
Yeah. Don't they go into the Greek letters too?
No,
they don't do that, Bruce.
Well, all the M letters are assigned to Messier objects, aren't they?
Right. Well, that's an entirely different catalog.
right.
Still, you say M81,
Same with the Greek. The Greek letters are for I think the Bayer designation. So you start with, alpha, beta, gamma, and it's not even in magnitude order. Some of them are done in right ascension order. So it's a pretty jumbled up, chaotic thing that's inherited from the past.
And Chuck, do you know the fourth letter of the Greek alphabet?
Delta?
Gampa.
Yeah.
Right?
Gampa.
Does it go gamma to Gampa? Yeah. By the way, you were right. Yeah.
I was thinking about offering up the Tom Whittemore pun of the week.
Yeah.
That's one of our regular features, but I don't think I have to.
You gotta have.
Okay, so R Leonis and the constellation Leo the Leon. My quick dumb question of the week, I'm going to allow myself that because I'm fascinated by this binary thing. Half the stars, more than half up there, are in systems. They're not single stars. How many of those can you guys see in your telescopes separated individually, two rotating around each other, or three? Or do they?
It just depends how big your scope is.
Yeah.
If I put my scope into a deep sky tour, it shows me a number of the double stars, and I generally can resolve them if it isn't too turbulent.
Well, are some of these variables we're talking about part of such systems? They're the bigger or the smaller that goes up and down?
Yeah, some of them are eclipsing binaries.
Okay. And a lot of them are on edge and they'll transit each other. And
that's the eclipsing binary.
Oh, that's what that's called. But most of them aren't on. The odds of them being on edge would be low, wouldn't you think? They're all different angles.
Yeah.
We got about 2 minutes to cover a couple of things. A reminder, Santa Barbara Astronomical audio podcast is every morning, 11 o'clock every Monday morning. And if you want your newsletter, Tom, you did a good job. Tom Whittemore.
Thank you.
If you're in the club and you haven't got a newsletter yet, like Mike Hardwick, who's a longtime member, but he says that he doesn't think he's paid his dues. I told him to get in touch with Mr. Colin.
We are suspending all that due stuff.
Yeah.
Everybody that was a member when the pandemic started will come out of the pandemic as a member in good standing. Then we'll talk about dues.
All right.
And I'm pretty sure that his name is listed as a member right now in the email, so he should be getting our emails. You should ask him about that.
I think he emailed me at one point and asked what was going on, and I told him that we had just suspended all of processing a membership.
Well, he himself doesn't own a telescope anymore, but he's got a son who's a cinematographer, lives down in Simi Valley, and he's got about a 10-incher, and he's out there at night, and the guy works for Netflix, and we should have him, I guess. What do we know about VCAS? Are they meeting together, or are they still online? That's Ventura County's
They're
the
still
sec-
mainly online.
They're
Yeah.
mostly online. Okay, and any estimates, Mr. President, Jerry, about when we might go back to meetings? Summer?
Well, just watch Dr. Fauci.
Well,
And the
Good.
museum has suspended astronomy activities for at least the rest of the year. So I don't think we'll be
Okay.
doing anything there.
Who has-
Actually, I think it might be time for us to reach out to some astronomy professor or grad student and see what their research is and do a Zoom meeting with them. I think it could work. And we
Yeah.
just advertise it to our members and give it a try, just like we do a meeting like this. So
Yeah.
I think, Ron, if you want to grab somebody and see if they want to do a Zoom presentation with us, I think it would work out fine for our membership.
you mean as a special Zoom, not on our Monday podcast?
Right. Right.
I'm new to this, so tell me, is there an infinite number of pictures you can get on a screen of everybody? Including
Well,
the
no,
speakers?
I think the license the museum we're using from the museum is about 150 people, so it should cover the normal range of folks that we have show up at a meeting. So we can
Yeah.
see. So
Wow.
Okay, and you, Mr. Totten, will let us know if comments pop on the YouTube screen. You got that on your
yeah,
screen?
Tim Crawford was actually popping up there. His one question was, how will we make breathable air from materials on Mars? And I sent him a link to the MOXIE generator that's on the Perseverance rover. So, but that was the one comment. We did have up to 6 people watching at one point. The 3 are watching right now. So it might be Tim, myself, and someone else.
Okay.
Okay.
We've run out of time. Next Monday, we'll be able to talk about the flight of Ingenuity. And you want to go to SBAU.org, join up, see us on YouTube. Remember, tomorrow night, online telescope workshop, possibly a half-hour version followed by a virtual tour of Mount Wilson. Gentlemen, take
I
care of
want to
yourself.
pass on one thing.
Thanks,
Okay.
Tom.
Charles Schuler and I have been getting away from Goleta. And the last Friday, we went up to West Camino Cielo, up Refugio Road, and we were at 2,600 feet. The seeing was just incredible. And so, if you want to be part of that, we can certainly include you in our group.
Sure.
Okay.
Freeze our garbanzos off with Bruce.
Bye,
I wear
everybody. Bye.
I wear ski clothes.
Well, I miss those parties on the side of Lake Cachuma, the food and man, oh man, the wind. Let's get together with our wives right now, put our mask back on and stay safe. I know we've all been inoculated, but we got to weather this out. Gentlemen, I'll see you next Monday, 11 a.m. sharp on screen.
Thanks, Ron. Thanks, Tom.
Thank you. Bye-bye.
Thank